Yeah. So this panel will be about zk, especially in technology side, to discuss about the technology progression and application, because obviously zk can be used as a scalability solutions and also in privacy solutions. So I'm Ray from iOS Ventures. I'm investment director, fully focused on investment research. And today we also have some guests focused on different area in zk side. Yeah, to begin with, maybe you guys can give a brief introduction of yourself and your project, the things you are building. Yeah.
Yeah. Hey, I'm Adrian. I'm the co-founder of Anoma as well as Namada. Namada, very simply, does one thing and does one thing only, which is asset agnostic interchain privacy. Think you would like to have a single shielded set that supports any type of asset. And that can interoperate sort of across the rest of the interchain stack, so you can do things like shielded swaps with osmosis while still remaining private. So we can sort of use Namada to build a lot of sort of privacy tech into the rest of the ecosystem.
Hi, I'm Avi. I'm the Chief Product Officer at NIL Foundation. I know Anoma has done many things, to your credit. I like that framing, though. NIL Foundation has done many things, but today we are solely focused on NIL and Ethereum L2 based on zk sharding.
Hey, I'm Henry. I'm the founder of Penumbra. It's a shielded DEX app chain, so you can do on-chain trading with private strategies. Yeah, we do all kinds of zk, but all client side. So it'll be interesting to chat about.
Yeah, so my first questions, when I look back like 3-4 years ago, zk was still very early, but right now we are more mature and a lot of progression in both academic side and the technology product side. And so my first question is that what inspired you to start a journey back to 3-4 years ago? And what was the vision back then? And how about now? What's the status right now? Yeah.
Yeah, so I think zero-knowledge proofs are technically interesting, and I think this is actually where most of this stuff. I think a lot of people in this room came from this technical. Like, it's an interesting use of cryptography, right? I think this is what got me. I think over time, like, we can actually use this to build very cool tech that is going to really actually help end users. And I think fundamentally, without leveraging zk tech for either computational privacy or computational compression, this space will not be able to get any sort of large scale adoption. Like, I think, so right now we're looking at this kind of critically and say, well, people don't really care about privacy guarantees, for example. And I think they're wrong. Like, my parents will definitely care. Like, if we actually go sort of beyond this like pure meme coin trading thing, people are going to have to care about privacy guarantees long term. And I think this is really what excites me. And I think it's interesting in the sort of zk space where I think like the public discourse is very far ahead of what we can practically be building right now. And so I'm super excited here also with Namada. It's just like, it just does one thing. It's a very simple thing, right? But like, just like getting this one use case going of like, well, we can have private transfers that are asset agnostic, I think is going to be incredibly powerful.
Well, I've only been at NIL for 9 months, so I don't know why we chose to pursue this in the early days. But my own experience, why did I want to dedicate, say, my career to, this area? I had done my best to understand where the state of research was at in my previous life as an investor, and talked to a lot of people smarter than I am. I'm no researcher. But what I understood was we had come a very long way, very quickly, in the world of zk research. And that it would only be a few years until we would have real implementations of these ideas that would, say, unlock new use cases. So it does feel like we're sort of at this inflection point, but to Adrian's point, I think we've probably gotten ahead of ourselves. In the discourse.
So about, I guess, looking back 3-4 years, at the time I was working on Zcash, and it's kind of interesting and maybe a little bit of a contrarian view, but I felt then and also now that what was missing actually wasn't really anything about the zk tech specifically. Like, Zcash is kind of a proof of existence that you can build a functional system using the proving technology of 4 years ago, which, to be clear, was invented by Zcash, so that was how they pushed the boundary. But since then, I think that a lot of the barriers to adoption have not really been about the existence or non-existence of better zk tech. Certainly we've seen this kind of like relentless march of progress of better and better zk proving systems, and every time someone comes out with them, with a new one, there's an additional set of use cases that are unlocked. But there's a kind of fundamental problem, which is that once you're starting to build a system that uses zk to sort of rearrange the data and computation, then you actually have to start rethinking and re-architecting the system from the ground up. And that is a super hard and underrated problem.
Yeah.
Can I ask a question?
Yeah.
Because and I just said myself, it's like, the research is getting better, the implementations will get better, and then we'll get better zk products or use cases. And I'm curious, like, when you say better, what does that mean? Like, what is the quality of better in your mind?
So maybe to use a concrete example, if we look at what's happened with like zkEVMs or the sort of battle between optimistic rollups and zk rollups, if you rewind a few years, it seemed like optimistic rollups were this like very pragmatic sort of near-term solution, and it's just much easier because you don't have to deal with all this moon math and you can just ship something. And it ended up being that like actually people just like figured out the moon math and made zk rollups before people figured out fraud proofs. And that's the kind of like, there's a sufficient level of advancement in the zk proving tech that made that specific use case possible. But in that use case, part of the reason that there is a big advance in the proving tech needed is that it's done in a very kind of inefficient way, because you're just taking this existing system and certifying it, and you're not really building anything that has any notion of control over information disclosure. And that's really where the need to kind of re-architect systems comes in. Once you add the concept that information could be private or public to some people but not to others, this is this kind of fundamentally new design access for a blockchain. And no matter how good you make your zk smart contract language or your programming environment or whatever, there's no way that you can abstract away a kind of fundamental design point of like, if I want my system to have control over information, I, as the system designer or the app designer or the contract designer, I actually have to be thinking about what information is going to be revealed to which people. And that's not just a zk problem. You can make the zk tech like very good and make all the tooling good, but at the end of the day, that's a thing that the system designer or the contract designer actually has to start reasoning about.
Yeah, actually, to add to this, I think this is like one very underappreciated point with regards to zk tech, that like currently we all live in this world where all the state lives in this like large blob in the middle, and we sort of assume that we can use this large state in the middle that's fully transparent to coordinate with everyone, right? And so like when you think about how a lot of the agent interactions actually look like in the current transparent systems, it's like we keep modifying this like globally mutable state. And as soon as you start thinking, well, how do I want to have some more information flow control around individuals' data, it means that data starts moving to the edge devices. And yes, we can do super fast proofs on edge devices nowadays because the tech is getting very good. But we also have to rethink, like, how do we now allow like interactive things? Because like this fundamental architectural paradigm has shifted away from like large amounts of globally mutable state in the middle to like, well, all the state is sharded on every single device that's using the system. How do we actually now allow that I can sort of do a partial proof over my thing that I send to you, you then do a partial proof over your thing, we send it to someone else that sort of like aggregates all of these things and then actually updates the sort of Merkle tree in the middle just using proof verification. I think this is sort of like one of the big, and just like a very quick side note, like this is one of the big reasons why with Anoma we started thinking about intents, right? Like because this is like this fundamental shift away. It's like it's not just enough to add zk to your thing and go like, well, we now have private compute. Like this is not how this works. You have to rethink how your system is architected because fundamentally where the data lives is really important to allow actual use cases here.
Yeah, so if I understand correctly, both of your points are referring to sort of more robust privacy with the use of zk. Because there's often, many people, including ourselves, right? We aren't using zk for privacy today. Hopefully we will in the future. We're using it for compression. And do you want to chime in?
No, I'm
okay.
queuing.
Like people often say, if proof generation is faster, if it's cheaper, then we get better systems. But if you're using it like strictly for compression, you get better safety and liveness guarantees, but you're not necessarily unlocking like a new design space for applications.
Are you getting better liveness guarantees? Aren't we just like all aggregating our liveness guarantees into a single prover being available all the time?
Well, the faster that you can generate your proof and then say send it to this, maybe massive aggregated, prover. Sure. That's a very cheeky question, but
to chime in there, I guess what I would say to that is that I think right now there's a distinction between like zk for privacy and zk for scaling, and these are regarded as these two totally different things. But I do think that in the future and the near future of the next few years, those two design directions are actually going to converge. And you can think about that in two ways. The first is, suppose you're starting on the privacy side. By the time you build a system that has moved all of the end user data out onto the end user device, it's being scanned, locally indexed there, people are doing their execution locally, sending proofs back. This system actually looks very different from a performance standpoint because all that's actually happening on chain is just a bunch of proof verifications, and there's very little state access happening. On the other, and so that ends up actually being a dramatically more scalable system. So for instance, for Penumbra, right, you can use the Penumbra front end and the Prax wallet extension and you just aim it at any RPC, and you don't need to rely on some like big centralized indexer because all of that is already happening locally on your device. If we take the other direction, though, of like, let's say you start with, we want to do zk for scaling, and we're trying to just scale things up. You'll end up actually working back to the privacy angle from that direction if you keep pushing on scaling, because if you imagine a system where there's excess information disclosure, and that information is being propagated through the system, if you don't actually need to be sharing that information, but you're having to propagate it anyway, now you have additional state synchronization, you have additional communication overhead. It's not an optimal design from a performance standpoint. And so you know the problems that people run into where like, oh, there's this we now have to have like one really big prover that can prove like one giant state transition for everybody. Wouldn't it be a little bit more efficient if we could get each sort of chunk of activity to be making their own zk proof, and then we can like aggregate those? If you sort of follow this like aggregation layer sort of view out to the limit, you'll end up back in this privacy perspective where all of the computation is happening sort of as locally as possible, and just like certifications and proofs are being pushed inward to the center of the network.
I want to drive back a little bit. I think it's already touched some point, but I want to drive back a little bit because I believe there's some developers sitting here, and I think from investor and developers and engineers, what they more care about is more like a practical problem. What's the benchmark and of the cost of proof generation and verification, this kind of stuff. And when we touch that benchmark, we can support like some level of like high frequent use cases without like too huge like cost overheads. Yeah, maybe you guys can share a little bit.
Yeah, a little bit on this. I mean, I think for developers, one of the big challenges is that, and this is what we spend a lot of time on with regards to compiler design, on can we build high-level abstractions that actually abstract many different proof systems or many different circuit designs. Because I think fundamentally, over the last 3 years, the one constant thing that I've been reminded of is that I have no idea which proof system will be cool and like usable in 6 months from now, right? Like, so as a developer,
cool is important.
yes.
Yeah.
So as a developer, I'm like, okay, can we like build compilers, which is what compilers are designed to abstract the underlying hardware, the underlying sort of circuitry, chip design away from the developer, so that I don't have to rewrite my programs every time a new proof system comes out, right? And so this is what we spend a lot of time on with Juvix. On the proof generation timing, I think for better or for worse, we spend currently a lot of time trying to like optimize the zkEVM. The EVM was never designed to be an efficient circuit, like an efficient VM to be run in a circuit. Your life becomes a lot easier if you drop this notion, well, we should be backwards compatible to the like 50 relevant contracts in Solidity, and we should make sure that these 50 contracts keep running on the EVM, on a zkEVM. And so I'm pretty convinced that over time, we will just get actually better VM designs that are way more amenable to be run in a circuit, and that gets rid of a lot of the performance sort of problems. Because once we can have VMs that are designed for circuits, it is just going to be much easier to like build efficient proofs.
Yeah, I mean, so we chose to go with zkEVM.
That's a hard choice.
It's a very difficult choice, and you have to make a lot of compromises. But there is like a very logical like train of thought of why you would choose that, right? I mean, it is the most like popular and robust tool chain for building smart contracts. But yeah, I mean, if you ask like our cryptographers if they like that, if they enjoy it, they'll probably tell you no. I just want to quickly plug L2Beat, because I actually heard that they're going to be coming out with some like performance benchmarking stuff. They did zk catalog recently. So yeah, just follow the work that they're doing. I think they should have some good stuff soon.
On benchmarks, don't trust any benchmarks you see, because everyone that does a benchmark for their prover is like, oh, we have proved the Fibonacci sequence program. I'm like, great, this is like not a realistic program at all. Like these benchmarks, mostly on the GitHub readmes, are like pointless, because they prove like the most simple program possible and go like, yes, this is super fast.
Or you cherry pick, blocks. Yeah.
So, I mean, for Penumbra, the context is a little bit different, because rather than trying to do something fully general, we're focused on just the one specific use case of doing private transactions, private trading. And we made the mistake of trying to actually build a product, which is not the current meta.
How dare you?
The thing about that is that we don't really have the problem of like having the like fake benchmarks, because like it does actually have to work, and because of the specialization of like we're gonna zoom in on a certain set of fixed functionality, we're actually able to get the proving time for a sort of ordinary send transaction to be around 600 or 700 milliseconds on a laptop, and we have about a 20x slowdown to that when we go into the web browser, but that's still only several seconds, and we can basically do a kind of end-to-end complete transaction in about the same time that you would have to wait to get a confirmation on Ethereum. So that's kind of our personal benchmark for like, is this fast enough? Is like, if you can get it to be faster than the time that it would take for a user to review the transaction approval dialog, then it is effectively infinitely fast from the user's perspective, because you can finish the proving by the time that they actually finish deciding whether or not they want to make the transaction.
Did you guys have to do like any tricks to get the proving speed that fast, or that's applause, right? That's awesome. Yeah, what did you do?
I mean, basically the trick is that we didn't try to innovate on the cryptography part. We tried to innovate on like everything else. So if you have say there's 100 novelty points for Penumbra, I would say probably only 10 or 5 are on the actual proof systems. Our circuit design is a very clear evolution of here's the circuit design for Zcash, and we kind of just streamlined it, made some of the primitives a bit more efficient, and focused pretty much all the rest of our effort on how do you kind of put that into an end-to-end system where people are actually going to be able to get some kind of product value out of it. But the kind of intuitive explanation of where does the performance come from? It's well, we're fundamentally using similar levels of complexity of proof statement as happened in 2018, 2019 with Zcash, and so we just pick up 5 years of tech improvements for free.
This is actually the same case with Namada. It's also again taking the Zcash circuit designs and going, great, this is actually very fast. We don't have to innovate a lot on the cryptography side. We can just extend the circuits a little bit, and all of a sudden you actually get very fast end user proofs.
It's the astronaut meme. Is all Zcash.
I mean, yeah. I think one thing that is, not always publicly appreciated, and so I just want to take some time to do it, is that I think there's some sense in which the original deployment of Zcash was the Apollo project of cryptography. At the time that was deployed, it was the most advanced cryptographic system that had ever been built and deployed and made real. And you can trace the lineage of all of the people who worked on that, and then the people they worked with, and you can see the dissemination of ideas. And I think that, everyone should know that that was the monumental achievement that everything else is building on.
Yeah, I think we are nearly run off the time, but final question, share a little bit more about your next 6 months plan, whatever in your privacy product or very low level infrastructure, this compressed ZK infra, yeah.
For me, that's pretty simple. Roll out Namada. That's it. Provide asset-agnostic privacy guarantees to the Interchain. And then on the other side, a little bit, ANOMA testings are coming this summer.
So we just rolled out our DevNet on Sunday. We've got a group of developers using that, so going to continue collecting feedback, working with those folks. And then we'll have our testnet, which will be a more broadly available version in November.
So the Penumbra mainnet began about 7 days ago. So we're in a very early sort of decentralized phased launch. But
these things are really hard. When somebody says they launched something and it actually is usable, you should clap.
So if you go to the Penumbra forum, there's a description of the phased launch process, how people can participate. If you want to test it out, it's going to be super rough at the beginning because that's how decentralization goes. But it'll be up only from there.
Okay.
In terms of usability, I mean. Yeah.
Okay. If you have more questions, don't be afraid to approach our guests. Yeah. Thank you. I will stop here.
Thank you very much.
Yeah.
guys, we have like 2 more minutes. So if anybody has a question, I'm sorry, guys. See.
Yeah.
Go ahead, Dean. Here.
And as with everyone, I can neither confirm nor deny whether I participated in Penumbra. So my question is, there's zero knowledge for privacy, but it's sort of been interesting to see it popping up for other purposes, like, arm's length verification that the other guy did his job without me knowing what that is and stuff like that. I'm curious whether you guys, what are the other uses that are helping to drive that tech stack, and whether you engage in any of them, which ones are interesting and which ones are theater.
I think sort of the other use case that I'm quite interested in is how we can get privacy-preserving multi-sigs, for example, so like something similar to zk accounts, where it's unclear how many people are behind it. I think generally speaking, I like zk for computational compression because it will make a lot of our lives just easier, and it will make scaling easier because like the more data lives on edge devices, the less data we have to communicate over the network and into consensus, right? So this is the one use case I'm super excited about in terms of building really scalable system this way, where a lot of the where privacy is just like an accidental thing of good architecture design.
Yeah, I would agree with that. I think Eli from Starkware likes to call it computational integrity, which is the description of compression. And I think there's been some interesting new products that have popped up just lately where I think folks are excited about zkTLS and things like this. And can you maintain the quote unquote integrity of a computation that was never meant to say live within these decentralized systems and bring it into this other system. So.
So the other panelists had good examples, so I'll be the person to sort of give my theory of bad examples. I think a good heuristic to figure out whether some proposed zk thing is just NGMI is, does this have some kind of coherent theory of change? And a lot of the time, because you can do anything with zk, people will come up with these lists of oh, here are all these things that you could use zk for. And the example that I love to dunk on is a zk proof of income for a rental application, where oh, I could, when I'm filing for a lease, instead of having to give over my bank statement to this landlord, I could do a zk proof. And this is basically never going to happen, because there's no theory of change of why anybody in that situation would want to adopt this, or rather anybody who has the control, right? The excess information disclosure in a lot of our existing systems is actually, it's a bug to some people, but it's a great feature for other people. And just kind of realizing, oh, we could use zk for this is not the same as actually coming up with a coherent theory of how are the people who want to win with getting privacy from zk actually going to force the adoption of the technology that benefits them against the people who are currently kind of winning by learning too much information.
So actually, this is in the landlord case, I fully agree, right? But sort of on the business side, I'm actually somewhat more optimistic because, for example, if you're a bank, you do not actually benefit from the data. Now you have this massive thing that you must secure, you must keep up to date all the time. It'd be much easier for certain businesses to just go, well, I have these proofs, I can verify them, rather than having to maintain these massive honeypots that they now have to deal with. Keeping data is just expensive as fuck. And so I think I'm hopefully slightly more optimistic, at least on large corporations may actually want some of this, especially if their business model doesn't rely on selling the data. If your business model is selling the data, you will never want zk. So hopefully we'll get at least some people that want to reduce the compliance costs by just accepting a proof rather than oh, I have to manually verify these passports.